Hello, good morning or afternoon. This is my Lab 1 video for Physics 2211. In this video, we'll be looking at Newton's second law, or the momentum principle, and how we can use it to predict motion of an object with constant velocity. By using tracker software, we are able to collect specific data about an object moving at a constant velocity, such as change in location over certain time intervals, which will give us velocity. Using that data, we can then determine initial position and velocity to predict motion with a computer model. The reason Newton's second law and the prediction of movement is important is it's going to be one of the building blocks for any time we have objects moving, or especially objects moving while experiencing a force. As we can see in the equation up here at the top, the force net force acting on an object is going to affect our change in velocity, which of course will be important for predicting movement. In this specific lab, we're looking for an object with constant velocity, so this change in velocity will be zero, and so we're also hoping that a net force will be zero. Let's briefly look at the lab setup. Here in Tracker, you see I've got a soccer ball rolling across the floor. You've got a little book in the background to serve as our benchmark for distance. And you can see on the top right here how it is forming a graph of data points of position over time. From this data, we are able to collect an initial velocity from the first two data points, the change in time, or the change in distance divided by the change in time, giving us our initial velocity. And then we can take that data along with the weight of the ball and plug it into our GlowScript model. Here you can see how it models the same thing, position over time. Up at the top there, we've got our little ball moving to the right, just like we've got a ball moving to the right in our physical experiment. In order to get the equation or the equations within GlowScript to work how we needed, we had to make a few adjustments, setting initial position, ball mass, and initial velocity according to our experimental data. Then changing the velocity updater line and the position updater line to better reflect Newton's second law. Here we've got force net over the mass of the ball, just like we had it in our original equation. And we're also changing the net force to be zero because, of course, we're trying to model constant motion. So F net equals vector 0, 0, 0. Beyond that, let's look at the results we actually got. So here, the red line is our model. It's straight as you would expect with perfect constant velocity. And our blue line here is the experimental position. You can see at the very beginning they are similar, which is what we'd expect because the model, the computer model in red, is based off the initial movement of our ball. But you can see the ball starts to slow down, starts to get a little wobbly. That could be due to several things. Of course, we've got friction. Possibly the ball was a little deformed, not perfectly round. Or perhaps there was some like overestimation of the initial speed that offsets the movement of the model, overpredicts. You can see that it's an overprediction as the distance in meters over the same time period the ball has traveled much farther, as well as just looking at the slope of these lines. A more ideal experiment would have maybe a small plastic ball that could not be deformed, was perfectly round, and moving a shorter distance, so it doesn't have as much time to sort of slow down like the soccer ball did. Briefly, let's talk about the forces acting during the experiment. We of course have an initial force that kicked the ball to get it rolling, but that's not part of what we're modeling. What we're modeling is just the ball moving across. So in that scenario, we just have gravity pushing down and the normal force counteracting that. And so we'd hope that that means they counteract each other perfectly. There's no net force. But obviously things like friction are always going to apply in scenarios like this, and our ball is going to slow down. Otherwise, other than the slowing down of the ball, we can see that they're similar in type and similar in the basics of what they display. And we were able to, using the computer model, use Newton's second law to predict motion based off an initial set of data. Other than that, have a nice afternoon.